This video is all about introduction to surd. Now, we are going to talk about what is surd, rules of surds, reduction to basic forms, addition and subtraction of similar surds, rationalizing the denominators and conjugates. These are the items when after we must have discussed through them, you will be able to know how to solve surd problem. So now, let's begin. The first one was what is surd. Now, in simple term, I would say surd is a value in roots that cannot be further simplified into whole numbers. Now, examples of surds. Now, if a value does not have a perfect square, the root of that value is surd. Just like 5, let's say, let me just say like 2, 3, 5, 6, 7. Now, if you check, the square root of 2 is an irrational number. So 2 does not have a perfect square. But the square root of 4 is not a surd, because 4 has a perfect square. So because 2 raised to power 2 is 4. 2 times 2 is 4. So 4 has a have a perfect number. So the square root of 4 is what? 2. But the square root of 2 will not give you a whole number. Now, so in essence, we are saying that any value in a root that cannot be further simplified into a whole number is a surd. Now, and it's an irrational number. Just like this one, we give you 1 point. It will give you about 1.4142. Now, you see, this is not a whole number, but this one is a whole number, which is 2. So that means this one is not a surd. Why this is a surd? Because any value inside this root, this is a quadratic root, or we call it a square root. Now, inside this root, okay, now, like if you say cube root of 4, this one is also a surd, because this value inside here does not have a perfect cube. It does not have a perfect cube. But if it is like 3 square root of 4 raised to power 3, you can say this has a perfect cube, which is the answer will be 4. So you will say this is not a surd. It's just like which is either is the cube root of 64. You know, the cube root of 64 is the same thing as 4 raised to power 3. The cube root of 4 raised to power 3, which is 4. Now, you will say this one is not a surd, because the value inside the root, inside the cube root, is a cube. It's a perfect cube. It's a perfect cube that will further be simplified into a whole number. But this one, square root of 2, cannot be simplified into a whole number. Just like if you have the square root of 3 The square root of 3 cannot be simplified, can not be further be simplified into a whole number. Instead, it will give you a number 1.7, about 1.73205, with more other numbers coming up. So it means that surds are irrational numbers. So they are not rational numbers. So that is surds. Now let's look at let's look at the rules. The rules for surd. Now, rule number 1, if you have, let's say the square root of a times b is the same thing as the square root of a times the square root of b. Now, let's prove it. Now, the square root of 9 times 16 is equal to the square root of 9 times 16. 9 times 16 will give you what? 1444. And the square root of 1444 is what? 12. Now, let's look at this based on this formula. Let's prove this formula. Now, you have on the left-hand side, we have the value to be 12. Now, let's look at the right-hand side. The right-hand side, they said this expression is the same thing as saying the square root of 9 times the square root of what? 16. The square root of 9 will give us what? 3. Times the square root of 16 will give us 4. So 3 times 4 will give us what? 12. So the right-hand side is equal to 12 and this is equal to 12. So it means that this expression is equal to this expression. Then the next one, the second rule, they said the square root of a divided by b is equal to the square root of a divided by the square root of b. That is, the square root of a divided by b is equal to the square root of a divided by the square root of b. So now let's look at it now. Let's say the square root of 144 divided by 16. So 144 divided by 16 will give you 9. So the square root of 9 is equal to what? 3. Now let's look at the square root of 144, which is the left-hand side, divided by the square root of 16. Now the square root of 144 will give us what? 12. The square root of 16 will give us what? 4. 12 divided by 4 will give us 3. So you see, they are the same. So the left-hand side and the right-hand side is the same. So it now means that the rules for surd. Now, if you see the square root of a times b is the same thing as the square root of a times the square root of b. Now, the square root of a divided by b is the same thing as the square root of a divided by the square root of b. There is also another rule. Note that the square root of m plus n is not equal to the square root of m plus the square root of n. This is not equal. So let's say, for instance, you have 16 plus 9, the square root of 16 plus 9, which is what? 16 plus 9 will be 25, the square root of 25, which is equal to 5. Now, the square root of, let me, I want to prove I want to show you that this one, you cannot. Let's go to the next page. The square, note that the square root of m plus n is not equal to the square root of m plus the square root of n. Now let's look at an example. The square root of 16 plus 9 is equal to the square root of what? 25, which is equal to 5. Now the square root of 16 plus the square root of 9. Square root of 16 is 4, plus the square root of 9 is what? 3. So 4 plus 3 is what? 7. So you see, 5 is not equal to what? 7. So the left hand side is not equal to the right hand side. Now another rule again, if you have m minus n is not equal to the square root of m minus the square root of n. Like, let's say example, the square root of 16 minus 9 is equal to the square root of what? 16 minus 9 will give you what? That will give us what? 7. So you have the square root of 7. You cannot simplify this further. This is a surd. Now let's look at the square root of 16 minus the square root of 9. So the square root of 16 is 4, minus the square root of 9 is 3. So this will give us what? 1. So you see, 1 is not equal to the square root of 7. So now let's write the rules. The rules for, okay, let me say the rules for surd. The rules for surd is that the square root of a times b is equal to the square root of a times the square root of b. Then the square root of a all over b is equal to the square root of a divided by the square root of b. Now the square root of a plus b is equal to, sorry, it's not equal to the square root of a plus the square root of b. Is not equal to, this means it's not equal to. Then there is another one, the square root of a minus b is not equal to the square root of a minus the square root of b. So these are the rules. These are the rules. Although in books, they don't put the third and the fourth rules. They just give you, they just state a warning that this is not equal to this. But I'm trying to give it to you so that when you see them, you will now be able to know that, okay, this is not, you, in your mindset, you also, you know that, okay, this is not equal to this. That I will not consider this to be equal to this. So now, in that sense, you will not be able to make mistakes while solving surds problem. So now, let's look at the next section that we want to consider now. We want to consider reduction to basic form. Now, if you have a number that does not have a perfect square in it, then the roots, now, but what we want to be considering here now is square root, or we call it quadratic root. So now, if you have a value like 5 is a basic form because it does not have a perfect square in it. Now, if you have something like this, let's say, let me give you an example. If you have something like 8, square root of 8 in it has a perfect square. So since 8 has a perfect square, this is not the basic form. Now we need to reduce 8 to its basic form. So to reduce 8 to its basic form, now we look at the factors of 8 that has a perfect square. Now what are the factors? Like now you have 4 times 2. 4 is a perfect square. So now applying the rules of surd, where you say the square root of a times b is equal to the square root of a times the square root of what? B. So that means the square root of 4 times the square root of 2 will be equal to this. Now the square root of 4 is what? 2. Now the whole of this thing will now be 2 root what? 2. Now we have reduced this surd into its basic form. So this is the basic form of this surd. Now you will reduce it in such a way that it will now have a value in a root that does not have a perfect what square. Like this 2 doesn't have a perfect square in it. So we have reduced it to the basic form. So this is the basic form for this particular issue. Now let's look at some problems that you may be asked to reduce into the basic form. Like now, let's say for instance, let me just say simplify. Now you have the square root of 18. Now the square root of 18, now you can further reduce this into its basic form, because this is not the basic form of this expression. Now 18 has a perfect square in it. The perfect square inside 18 is 9. Now you say 9 times 2 is not 18, is 18. So the square root of 18 is now equal to square root of 9 times 2. And now applying the surd rule, where you say the square root of a times b is equal to the square root of a times the square root of what? B. Now this will now be equal to the square root of 9 times the square root of what? 2. The square root of 9 is 3 root what? 2. So now you see, we have simplified this into its basic form. So we have reduced it into its basic form. So this is the basic form, because this 2 now does not have a perfect square in it. Now let's look at another number, the square root of what? 60. The square root of 60, we will now look at the value of 60 that has a perfect square in it. Now you know 60 times 1, the two factors of 60, now when you multiply them together, it will give you 60, and it has a perfect square in it. Now 60 times 1, there is no perfect square in this. Now 4 times 15. 4 times 15 will give you what? 60. And now you see 4 is a perfect square. So that means you say 4 times 15. The square root of 4 times 15 is this. So that means to reduce this further, you say 2 root what? 15. You see, 15 does not have any perfect square in it. So this is how you simplify this. Now let's say they gave you another problem. Let's say you are given the square root of 45. Now you know 45, 3 times 15 is 45, is it not? But when you check here, there is no perfect square inside this. But 9 times 5 will give you what? 45. Now if you check, there is a perfect square here. So this 45 has a perfect square in it. Now 9 times 5 is this 9 times 5 will give you 45. So the square root of 9 times 5 is the same thing as the square root of 45. And applying this same rule, you now have square root of 9 times the square root of what? 5. This will now give us 3 root what? 5. So this is the basic form of this value. That is the basic what form. Now let's look at another number. Let's look at another number. We have, say, okay, find the square root of 400 and what? 5. Now 405 has a perfect square in it. Now if you say 81 times 5 will give you 405. And 81 is a perfect square. So applying this surd rule, you say the square root of 81 times the square root of 5. So that means this will give you 9 square root of 5. So that is the same. This now we have reduced this expression to its basic form. This is the basic form because we have reduced it to in such a way that this value inside this square root does not have a perfect square in it. So that is what we call reduction to basic form. So now if they give you a value that is the square root of a value that you should reduce it to the basic form, this is what they mean. That is what they mean, to reduce it to a basic form. So that is it. So now let's do some other examples again. Let's say you have the square, they gave you the square root of 98. The square root of 98, 49 times 2 will give you 98. Now the square root, now applying the surd rule, now it means that the square root of 49 times 2 is the same thing as the square root of 49 times the square root of 2, which is the square root of 49 is 7 root 2. So that is it. See, this is the basic form of this square root of 98. Now let's look at another one. Let's look at another one, the square root of 162. The square root of 162. So 81 times 2 will give you 162. Now the square root of 81 times the square root of 2, applying this surd rule. So the square root of 81 times 2 is equal to the square root of 81 times the square root of 2, which is the square root of 81 is 9. This is 9 root 2. So this is the basic form of this expression. Now let's look at another issue, which is what? Rationalizing the denominator. Now, in rationalizing the denominator, if you have an expression like this, square root of 2 divided by 2, you cannot simplify this further. But if you have an expression like this, 1 all over root 2 or 2 all over root 2, you can simplify this further. That is rationalizing the denominator. Now, rationalizing the denominator is to, now, if you look at the denominator for this whole particular issue, the denominator has an irrational number. This is an irrational number here. Now, let me say an example, a general example, a generic example. 1 all over the square root of a. Now, this a is an irrational, this expression here is an irrational number. Since a is not a perfect square, or does not have a perfect square in it, So A is said to be an irrational what numbers. You know, when a number is said to be a perfect square, it's just like 16. 16, that means 4 times 4 is a perfect square. Now, if you say 20, 20, you have 5 here, you have 4. So this is not a perfect square. This is just like a rectangle. But for 16, it has a perfect square. So if A is not a perfect square, now, then the denominator is irrational. Now, to rationalize the denominator of this expression like this, when you have something like this, to rationalize the denominator, what you do, you multiply the value of the denominator, you use it to multiply both sides. Now, 1 times square root of A will give you square root of A. Square root of A times the square root of A will give you what? A. So you see, this is now a rational denominator. We have rationalized the denominator. Now, if you have something like this, 1 all over the square root of 2. Now, to rationalize this denominator, what we're going to do is just say 1 all over the square root of 2, let's say times 1. And they say 1 all over the square root of 2 times, you know, the square root of 2 divided by the square root of 2, this will give you 1. So 1 times the square root of 2 is what? The square root of 2. The square root of 2 times the square root of 2 will give you 2. So we have rationalized the denominator. The denominator is now 2. And this expression here is the same thing as this one. So if you have an irrational denominator, this is the way to rationalize the denominators. Now let's solve some problems that is pertaining to rationalizing the denominators. Now let's look at a particular problem. Now let's say you have 2 divided by the square root of 2. This will give us 2 all over the square root of 2 times the square root of 2 divided by the square root of 2. See? Now, this times 2 times the square root of 2 will give you 2 root 2. Square root of 2 times the square root of 2 will give you 2. So this 2 will cancel out this 2. You now have what? The square root of 2. So that is the value. That is it. Just simple. Or if you have something like this, let's say you have 1 all over 2 root 2. This is the same thing as saying, you can say the square, you can say 1 all over 2 root 2 times root 2 divided by root 2. This can rationalize the denominator. So 1 times root 2 will give you root 2 divided by 2 root 2 times root 2 will give you what? 4. So this is the expression here, because now you know root 2 times root 2 will give you 2. So 2 times 2 will give you what? 4. That is it. That is it. So now let me just, now you can also express, you can also reduce the denominator further by saying, let's say you say 1 all over the square root of 2, the 2 root 2 times 2 root 2 divided by 2 root 2. That is using the denominator to multiply up and down. So 1 times 2 root 2 will give you 2 root 2 divided by 2 root 2 times 2 root 2. 2 times 2 is 4. 2 root 2 times 2 root 2 is 2. So 2 times 4 is what? 8. So 2 divided here 1. 2 divided here is not 4. So you have square root of 2 divided by what? 4. So you see both of them are the what? The same. So you can choose which way to use the method you're going to be using. So now we I'm going to also do, so having explained this, let's now go to addition and subtraction of similar sorts. So we now go to addition and subtraction and subtracting similar sorts. Now, example, a sword is said to be similar. Let's say if you have a square root of a plus 2 square root of a minus square root of a. Now, if you see this expression, this square root of a, square root of a, square root of a, you see they are similar. So you can add this. This is 1. This one is 2. This one is also 1 here. There's an imaginary 1 here. So you can add these two, which will give you, this is, okay, let me use factorization method. Now, if you factor out square root of a, you have 1 plus 2 minus 1 times the square root of a. It's the same thing. So 1 plus 2 is 3 minus 1 is what? 2. So you have 2 root a. So this is what they mean by adding similar. It is similar. Now let me give an example that is also similar. Now let's say you have the square root of 72 plus the square root of 8. Now 72, this 72 has a perfect square in it, and this 8 has a perfect square in it. We need to reduce it to its simpler, its basic form. Now 72 is the same thing as 36 times 2. So you can say the square root of 36 times 2 is the same thing as 72. Now plus square root of 8 is the same thing as the square root of 4 times 2. Now if you see, 36 is a perfect square, 4 is a perfect square. So we can now say, using sword rule, where you have the square root of a times b is equal to the square root of a times the square root of what? B. So that means square root of 36 times 2 is same thing as the square root of 36 times the square root of 2. Plus this one will also be the same thing. Applying this rule here, you say the square root of 4 times the square root of what? 2. So the square root of 36 is 6 root 2 plus the square root of 2 is 2 root 2. You see, these are similar sort because this is square root of 2. So we see the square root of 2 is common. If you want to use factorization method, since square root of 2 is common, factor it out. But without doing that, we can just add them together. That is adding similar sort without factoring. Factoring means you're trying to expatiate it further. Now, since they are similar, we can just add this to this term that are at the front. Just say 6 plus 2 is 8. So you say 8 root 2. Simple. See, that is addition of sorts. That is just addition of sorts. Let's look at another example. Let's look at another example. You have the square root of 27 minus the square root of 12. So 27 has a perfect square in it, and 12 has a perfect square in it. So now, if you look at 27, you have the square root of 9 times what? 3 minus 12 is the square root of 4 times 3. Now, applying the surd rule, where you have the square root of a times b is equal to the square root of a times the square root of what? B. So applying this rule, you now have the square root of 9 times the square root of what? 3. Minus this now with square root of 4 times the square root of what? 3. So this will give us the square root of 9 is 3. This 3 root 3. Minus this will now be 2 root 3. Now if you look at this, they have similar surd, which is root 3. So for you to the only what we are going to do to subtract this, you just say 3 minus 2 is what? 1. So this 3 minus 2 is 1. So if it is 1, so you just say root 3, because there is an imaginary 1 here. So that is the answer. Simple. Now let's look at another problem. Let's look at another problem. Now you have, let's say for instance, the square root of 112 minus the square root of 28. Now the square root of 112, you can now say, now let's say, 16 times 7 is the same thing as 112. So the square root of 16 times 7 is 112 minus the square root of, now 28 is same thing as 4 times what? 7. So the square root of 4 times 7 is what? The square root of 28. So now applying this surd rule, you have now the square root of 16 times the square root of what? 7 minus this one will be square root of 4 times the square root of what? 7. So this will give us the square root of 16 is 4. So this is 4 root 7 minus this is 2 root what? 7. So since they have similar surd, which is root 7. So since they have similar surd, which is root 7, we just, the coefficient that is at the front, we just subtract them. 4 minus 2 is 2. So it's a 2 root 7. Simple. That is the answer. That is how to say you're subtracting or you're adding a surd. Now, we have done rules for surds. We have run what is surd, rules of surds, reduction to basic form. We have done addition and subtraction. Adding and subtracting similar surds. We have done rationalizing the denominator. We have done rationalizing the denominators. Now, the last one. Let's see. We have done reduction to basic form. We have done rationalizing the denominator. We have done adding and subtracting similar surds, which is what we did now last. Now, okay, rationalizing. Okay, conjugates. The next is what? The conjugates. So now let's look at conjugates. Now, a conjugate. Now, if you have a number, you have A, let's say A plus square root of B. The conjugate of A plus the square root of B is A minus the square root of B. What it means that the conjugate of this is just to change the sign here. Now, the conjugate should have an opposite sign. Just like if you have A minus the square root of B, the conjugate will be A plus the square root of B. Now, if you have minus A plus the square root of B, the conjugate will be minus A minus the square root of what? B. This sign here should have it should be opposite. So that is the meaning. And the conjugate of a number, when you multiply both, even you multiply both of them, it will give you um a rational number. It will give you a number that is not a surd, that is not a surd number, it's in a surd form. Just like if you multiply these two together, if you say a plus root b times a minus root b, this will give you, this is just the same thing as when the signs are different, it's just the same thing as saying this times x, a times a, you now say minus this times x, so which is square root of b times the square root of b. This will give you a square minus b. That is it. You see, this is not, this is now a rational number. But you know, this form is an irrational number. It's an irrational, but this form is a rational number. Now let's do some example. Let's look at some examples. Now, you can also say like the conjugates of a surd, the conjugate of surd, nah? Conjugate surds. Let me call it conjugate surds. Now, if you have a number like this, now you're asked to simplify this further. Now, you need to simplify it in a form that it does not have a further simplifications. Now, it means that we are going to use, what we're going to do is that we need to make this denominator a rational number, because the way the denominator is an irrational number. It has radicals, so it's an irrational number because it has a surd in it. Now, for us to remove this surd in it, we're going to use the conjugate of the denominator to multiply both the numerator and the denominator. So what we're going to do is we say 1 all over 3 minus 2 root 2 times 1 is the same thing as saying 1 all over 3 minus 2 root 2 times the conjugate of 3 minus 2 root 2 is 3 plus 2 root 2. Now, you use the conjugate of the denominator to multiply both the numerator and the denominator. So now, you see, I'm using this value to multiply the up and also use it to multiply the down. Now, this divide by this cancel itself is 1. It's still the same 1. So it means that this whole expression is the same thing as this. So it will now be equal to 1 times 3 plus 2 root 2 will give you 3 plus 2 root 2. And this, if you multiply this times this, it's just simple. There is no need to expand further. You just say this 3 times this 3. Since the signs are different and you see they are the same, now you just say this 3 times 3 is 9. Minus, because this minus times plus is minus. Now you now say this value times this value, simple. That is 2 times 2 is 4. Root 2 times root 2 is what? 2. 2 times, that means 8, that is this 2 times 2 is 4. 4 times 2, what is 8? So it's what, just be 8. So that this one now will now be 3 plus 2 root 2 divided by just 1. So the answer, the simple form of this is 3 plus 2 root 2. Simple. Very simple. That is it. So that is the help of, this is the applications of the conjugate surd. Now, if you use, the conjugate surd can help you to rationalize the denominator. Now we have rationalized the denominator of this particular expression by using the conjugate to multiply the numerator and the denominator. We just rationalize because the product the product of the conjugate source will give you a rational number. So in that form, you have rationalized the denominator. And if you rationalize the denominator, you have simplified it into its basic what form. So let's look at some problems in this regard. So now let's look at another problem. Let's say they give you 1 all over 2 root 3 plus root 5. So this is the same thing as saying 1 all over 2 root 3 plus root 5. Now I will use the conjugate of this denominator to multiply both sides. So now you have 2 root 3 minus root 5. Just only what you're going to change is just this sign here. So you use it also to multiply the denominators too. So 1 times 2 root 3 minus root 5 will give you 2 root 3 minus root what? 5. Now this times this is just the same thing as saying if you multiply this and this, then you multiply this and this, simple. And this sign and this sign, simple. Just like let's say 2 times 2 is 4. So root 3 times root 3 is 3. So 4 times 3 is 12. Now you have 1 plus times minus will give you minus. Then root 5 times root 5 will give you what? 5. Simple. Simple, very simple. Just like you say 2 root 3 minus root what? 5 divided by 12 minus 5 is what? 7. Simple. Now this can also be expressed as 2 divided by 7 root 3. That is using this denominator to divide each of these terms. So minus 1 all over 7 root 5. Simple. That is it. That is a final solution to that particular problem. Now let's look at another issue. Let's say you have 2 root 2 minus, okay, let's do it in another. You have a problem like this: 2 root 2 minus 3 divided by 2 root 2 plus 1. Now this expression is the same thing as saying 2 root 2 minus 3 divided by 2 root 2 plus 1. Then now you multiply both the numerator and the denominator by the conjugate of the denominator. The conjugate of the denominator is 2 root 2 minus 1 divided by 2 root 2 minus 1. So now let's use a bigger space. Now we'll now use this to multiply the whole of this. So 2 root 2, it will just be 2 root 2 times 2 root 2 minus 1. Then we use this one to multiply the whole of this, which is minus 3 into 2 root 2 minus 1 divided by. Now this one, since it's the conjugate, you just multiply this and this, this and this, this and this. So now let's multiply this and this. So now you have 2 times 2, 4. Root 2 times root 2 is 2. So 4 times 2 is what? 8. Now plus times minus is minus. 1 times 1 is 1. So that is it. So now let's open up this bracket. This 2 root 2 times 6 will give you what? 8. Now 2 root 2 times minus 1 will give you minus 2 root 2. Minus 3 times 2 root 2 will give you minus 6 root 2. Minus 3 times minus 1 will give you plus 3. Now you now have here to be what? 7. 8 minus 1 is 7. So you will now add this plus this. They are like terms. They are similar. So 8 plus 3 is what? 11. This is similar to this. So now you have a similar surd. So we just add the the coefficients. The coefficient of this is minus 2 minus 6 will give you minus 8 root 2 divided by what? 7. So this is something as 1 all over 7 minus 8 root 2 all over what? 7. So that is the final answer to that particular problem. Now let's say they gave you another problem. They give you 1 all over 1 minus root 3 all squared. First, what we're going to do is to simplify the denominator. So you just say 1 all over 1 minus root 3 times 1 minus root 3. So that is the same thing as 1 minus root 3 all squared. So that is it. So now we can now expand that further. You say we use this to multiply this. You say 1 times 1 minus root 3. We use this to multiply this whole thing also again. You have minus root 3 times 1 minus root 3. So this will now be 1 all over 1 times 1 is 1. 1 times minus root 3 will give you minus root 3. Minus root 3 times 1 will give you minus root 3. Minus root 3 times minus root 3 will give you plus 3. So this will give you 1 all over 1 plus 3 will give you 4. Minus root 3 minus root 3 will give you minus 2 root what? 3. Now, you see, when you look at this, 2 is common. You say 1 all over 2 into 2 minus root what? 3. So this can also be written as 1 all over 2 minus root 3. So what we're going to do now, we use the conjugate of the denominator to multiply the numerator and the denominator. So the conjugate, we're going to also only use the conjugate of this expression here to multiply the denominator and the numerator and the denominator. So you say the conjugate of 2 minus root 3 will give you 2 plus root 3 divided by 2 plus root 3. 1 times 2 plus root 3 will give you 2 plus root 3 divided by, so now this is 2 here. Now to express this, is just say 2 times 2 is 44 minus root 3 times root 3 will give you 3. So this is simple as 2 plus root 3 divided by what? 2. Simple. Which can further be expressed as 2 divided by 2 plus square root of 3 divided by 2. So which is 1 plus half root 3. So that is the final answer to that particular problem. Now, let me just give you a table. Now, let's say we have numbers. Now we say we give you decimal, we give you surd or not surd. Now this, I just want to further explain what are surds. Now, if you have a number, let's say root 2, this root 2, the decimal of it is 1.4142. Why? You see, this is a what? It's a surd, because why is a surd is because the value in this root this is a square root. The value in this root does not have a perfect square in it. So it's an irrational number. So that is why it's not surd. It's a surd. So now you have, let's say you have square root of 3. This will give you 1.73205. This is a surd. You see? Then let's say the square root of 4. See, 4 is a perfect square. And it is 2 times 2, which is 2 to the power 2. So this will give you 2. So this is not a surd. It's not a surd. Okay? Not a surd. So now if you have, let's say, square root of, or let's say cube root of 125. This is same thing as, so this it has a perfect cube here. So this is cube root. So cube root of 125. So this has a perfect cube, which is 5 cube. So you now say 3. The cube root of 5 root 3 will give you what? 5. So this is not a surd. It's not a surd. But now the cube root of 25 is a surd. It's a surd because it will give you what? 2.9, let's say 2.9240. So this is a surd. This is a surd because 25 is not a perfect cube. This one is not a surd. This is a surd because 25 is not a perfect cube. This is not a surd because 4 is a perfect square. This is a surd because 3 is not a perfect square. This is a surd because 2 is not a perfect square. So I'm just trying to re-explain surds. I'm trying to say that if a value in a square root or a cube root, or let's say nth root, is not a perfect, either a perfect square, a perfect cube, or a perfect nth root, that will give you, that will be simplified further to give you what? A whole number, then it is a surd. If it will not give you a whole number, it will not be simplified further to give you a whole number, it is a surd. But if it will be simplified further to give you a whole number, it is not a surd. Like this one now gives us a whole number. It's not a surd. So thank you for watching to the end. Have a nice day.